Okay, so all right, we're now, now I think we're starting to feel dumber in here. I can't. Okay, long story. I'm not gonna waste your time with that. But a lot of you, I can see, yes, you've got your books out. But one of the things we just wanted to make a point is that as you make your way through this curriculum, okay, and we can just assign this as something that you should know. Okay, could that be a daily grade? Maybe. But how about we just tell you what this is? Because, oops, missed one. Okay. Okay, and then I believe that's correct. I just drew them from memory. But the point behind this is your clue. Okay? We're still working on this chart that we're talking about because I have refined it a little bit and certainly make a copy of this in hand to yourself. I think the smart thing to do would be to use text boxes and put this into a Word format and then maybe try to clean it up a little bit. But when we look at this, how do I want to ask this? We know those are hormones because that's what we're talking about. Are those steroid hormones? I would expect you to know that. Because this is the scientific name for the common name. So I'll ask again, are these steroid hormones? Well, what do steroids do? Don't they make you stronger? I don't know. I would certainly think that if you have some of this circulating throughout your blood that, oh my gosh, I feel like I could lift a car. You trying to tell me that's not a steroid? See, one of the aspects they want to do is critical thinking as well. So when you're shaking your head no, it's one thing to just say, yes, you're right, it's not a steroid hormone. But one of the things we want to say in here is, why are you right when you say that? You just flipped a coin in your head and came out tails, and tails, we're going to say it's a non-steroid. See, again, that's something that I would expect you to know. Why is this not, either one of these, a non-steroid hormone? See, you're trying to get that expert advice by talking to yourself, but when you do that, if other people can't hear you, how can it be expert advice?
Like you can have adrenaline and still play in the
Yes,
Olympics.
that's true. Unless it's I'm trying to say that too fast. Unless it's a synthetic form, then you'd be in trouble. It has to be naturally occurring. Yes, you're right. You can have this circulating throughout your body, and yeah, that is, of course, perfectly legal. So it still doesn't answer the question.
Like testosterone throwing, if you're not, like you can't have fake testosterone as a steroid.
Right, but you are on the right track on trying to answer this on why this is not a steroid hormone. You were so close. Well, yeah, it produces this too, but it doesn't quite answer. Testosterone, cortisol, aldosterone, estrogen, those all have one thing in common. They're derived from cholesterol. All steroid hormones are derived from cholesterol, which obviously this certainly is not. There again, we're missing our 2 seniors in here. Well, 4 seniors, but just 2 of those are in the which will essentially be the biochemistry class, where this gets to be more important when you start talking about the actual chemical structures of these and also amino acids. So some of these actually do have characteristics in common, like this, because we heard one of your senior classmates answer this question. Okay, we'll just kind of keep this a little simpler. But we do have just enough of a background of organic chemistry from when you were freshmen, but you probably just don't remember that. This is a very specific structural categorization. Does anyone possibly remember? Okay, we're going back 2 years now. Okay. Say that again. Okay. We'll just abbreviate that. It's kind of cool. Yeah, isn't that cool? It's AC. Yeah, that's cool. Well, I'm just seeing if we're actually paying attention here. So we'll continue when everyone finishes laughing. So we can proceed. All right. Then is there something similar here and here? Yes. Okay. So when it comes to organic and biochemistry, when you see these dashes and there's nothing written with those dashes, what type of bonds are those? Because we know, yes, this is a nitrogen to carbon, a carbon to carbon, a carbon to carbon, a carbon to oxygen. But if there's nothing written on there, carbon to what? A hydrogen bond. So what that means is this is NH2. This is also NH2, which is what we call an amine group. Okay? So then the reason that is important is because if you have an amine group here and an acid group on this side, this must be a specific what? Amino acid, which it is. Okay? So we're going to start putting some of these characterizations together. So what I want you to do is open up to page 490. Get to the right page as well. Okay. And actually, on the other side, 491, okay? Because when you look at your generic chart that you have right now, okay, which works just fine. It's not quite as full as this other one that I have. But looking at what you do see here on your chart, okay, what does aldosterone, estrogen, and cortisol all have in common? They're all derived from what substance? Because you said it earlier. Cholesterol, which means any steroid derived from cholesterol is what type of hormone? It's a steroid hormone. So then when you look at letter A there on page 491, we want you to be able to recognize that, okay, that is cholesterol, so that has to be a steroid hormone. One of two ways you would know that. One, we just told you. Two, you could recognize that as a steroid hormone because you could recognize the structure of cholesterol. Now, do any of these hormones that are steroid-based and non-steroid-based, do they possibly have similar functions? The answer is yes, okay? Because when we think of mineralocorticoids, what might be a steroid hormone that works with minerals and a non-steroid hormone that also works with minerals? That's one. and calcitonin is the other. Those are, and there's actually one more. No. That's the abbreviation, but why don't you just say then everyone knows too. You're not wrong. What is PTH? Parathyroid hormone. Does that confuse you when you hear PTH, TSH, or does that make it simpler for you? Would you rather hear thyroid stimulating hormone or parathyroid hormone? And maybe that makes it worse because those do sound similar. Okay, and that's fine. So PTH, and then you said calcitonin. Those are both mineralocorticoids. But then so is aldosterone. So why is that? Why is that? How don't you, we just told you. How don't you know? So with the other thing that you're working on, do you work on A&P when you're supposed to be in that other class or whatever? Sometimes. Huh. Do you think that's a smart thing to do? Probably not. So then why do we, okay, so then I was going to say, why do we do that? Just kind of like, if I hit myself in the head with a hammer, that hurts. Why am I doing that? No. Okay. But anyway, it is the content that we're going over here. We do want you to get this the first time around, because if you do, it just makes it a lot simpler. Okay. Now, also when you're looking at that chart, polypeptides and amino acids, they're both composed of the same substance because they do both make proteins, which proteins can also be hormones then as well, and that would make sense because when you look on page 491 at letter B, there is your PTH, or parathyroid hormone, which we know is a type of mineralocorticoid. So we've established that it's non-steroid. We've said what it is. We know that it's amino acid based, so that makes it a protein, but it doesn't explain what PTH does. So it has to be something with a mineral because we've established that as a mineralocorticoid. It has something to do with calcium. Yeah, it's going to raise the calcium levels, just like the calcitonin then will actually lower that as well. Okay, so categorically speaking, when you look at letter D then, okay, that's, as you can see, is oxytocin, which when you look at that table, which is table 11 or 13.3, oxytocin then is formed from what? It's a small table there. So you have to look through all those different types of hormones. Okay? It's formed from amino acids, but then it's a what type of compound? And I know that gets to be a little tricky when we look at that. Okay. So when you say peptide base, that's what we want you to know it as. That's exactly right. But when we say that, when you look at the chemical structure then of PTH as opposed to oxytocin, why would we say that it's peptide based and be able to say, okay, we can now tell the difference for two reasons? That's one of them. Yes, it is much simpler. Okay? Yes, those are your peptide bonds. So then that's why we call it a polypeptide-based hormone, oxytocin, which is not the only one. Does another hormone that is polypeptide-based, or excuse me, amino acid-based, but has polypeptides in it? There's one that I would like to think might look familiar because it works with aldosterone. It's right next door to it, to oxytocin. So then you got a 50-50 chance of TRH or ADH? Because one of those we talked about in class, the other one we have not. Why are you right? Because we talked about it. It means, and I think we only said a diuretic, okay, might be, well, not might be, but is something like this, okay, which is obviously a coffee cup. So what do we have inside of our coffee cup? Yes, coffee, but that doesn't explain what the diuretic might be. Caffeine. It's not the only diuretic. Alcohols can be diuretics as well, and perhaps even some certain types of sugars that if you have too much of that, okay, you're going to have to be able to excrete that throughout the body, okay? So then ADH, or anti-diuretic hormone, if a diuretic means, okay, if it dehydrates you, which caffeine does, what do you suppose an anti-diuretic would do? It's going to rehydrate you. And what that does is the ADH flips a switch, just like you could say, what does hydrochloric acid do to pepsinogen? Flips a switch and activates it. ADH, or anti-diuretic hormone, does just that. It flips a switch and changes and converts or allows you to take anti-diuretic hormone and secrete aldosterone, which then means you're conserving all these sodium ions, and what follows the sodium? Water. That's right. Okay. So the next thing I wanted to look at is some of these negative feedback mechanisms. The author goes in and talks about, or tries to illustrate that, as far as well, good thing we got 15 minutes left. I keep turning the pages till I actually find one. Okay, 514. To me, that would just look totally confusing, probably because we've never illustrated a negative feedback mechanism like that, okay? So if you had to do the programming or tell myself how to do that, or we could have someone else come up here and illustrate that negative feedback mechanism. Maybe that's even better. Because how did we do? Oh, we got our hand up. We got a volunteer. Your hand was up. Oh, okay. Yeah, I do that from time to time too. Yeah. You know, we were second class lever. I was illustrating the freshmen. See, I can give myself a haircut pretty quick. See, done. Yeah. You might think, but no. I think there's these four things called adenine, thymine, guanine, and cytosine that had something to do with it. Yeah. Yeah. My Dena did it. Okay. All right. Yeah, my Dena. Oh, DNA. That's right. Yeah. Okay. So when we look at this, they say blood sugar levels, but we're going to turn the tides on you a little bit, because to me, this, I'm going to actually go this way instead, because we've seen it the other way. Okay? Is that at homeostasis right now? No, it is not. Okay? So whether you're looking at this or here in the book, okay, normal blood glucose concentration right in the middle of what looks like, what, a figure 8, would you call it that? Yeah. Okay. So then, rather than doing that, usually we've done it this way. So we're just making this look just a little bit different. How could we illustrate a normal homeostatic level of calcium levels? There's blood sugar, but we're going to do something a little different. Okay? All right, so if calcium levels are elevated, okay, what is it that is a normal response or a negative feedback to bring this dotted line back down to a normal level that we need it? Calcitonin does that, okay? Okay? Well, what happens if our calcium levels drop too far and we need to actually raise that? Okay? It was an accident, but I see I've spotted a mistake. Oh, well, that too. You can't have two arrows pointing in the same direction.
Your calcium.
Seems like every time I do this, the very first arrow, we explain it right, but then we just don't draw it correctly. Okay. There. Okay. We were just seeing if you were paying attention. Okay. So then there must be something to counteract this, which it is, and that is what? Okay. Parathyroid hormone, okay, which then will increase those calcium levels. Okay. And I think, yes, I've got this on this new chart, which, again, we'll make readily available for you. I really didn't know what to think of this class as far as, okay, so what are we going to do? We're just going to do somewhat of a review and some of the things that we would expect, okay? So as far as hormones are concerned, we've got mineral corticoids, okay? What's another classification? We don't need polypeptide amino acids or anything like that. Glucocorticoids. Well, that's too specific. There's one more. Okay, which is also a glucocorticoid. We've got mineral corticoids, glucocorticoids, and then something that would differentiate between men and women. Gonadotropins, that's right. So then of all of those, we can still use your old chart for that. Okay. In your estimation, what is the most common classification? Yes, you could say non-steroids because, yes, there's more of those on there. But what appears on there the most? Mineral corticoids, gonadotropins, or glucocorticoids? Exactly. That appears on there, oh gosh, or even has an effect on glucose. We could say insulin does, glucagon does, and for the reason that you might not realize, epinephrine does, norepinephrine does. You don't know that because that's on here. And then, of course, and then also thyroxine, and then cortisol. So it appears multiple times. It's got various functions. It also has so many different various structures because some of them are cholesterol-based, like cortisol, and some of them are polypeptide-based, and some of them are amino acid-based. Okay, so I think that's enough for today. Tomorrow, don't forget, you have a short evaluation, and then we will proceed, get you ready for your final, which is, I want to say 2 weeks from yesterday. I think that's accurate. Maybe it's 3 weeks. Okay. But regardless, we will catch up to you next time.